All right, before we take one more look at, cost, revenue, profit type stuff, I did want to take a look at sort of one of the economic supply-demand type market equilibrium problems that end up arising, where a quadratic function appears. Now, from looking at the equations given in this example that talks about finding a market equilibrium, you might say, Professor Carroll, there's no quadratic here. I don't see a square anywhere. The real key to this is that unlike the equations we saw in chapter 1, you'll notice that the Q and the P term here are multiplied together. That's where the quadratic's going to end up coming out of this. So you might recall, we have tools for solving systems of equations. We can't quite use like an elimination type approach like we could have in chapter 1, but we can do a substitution thing. It's actually not too tough to get one of the variables in this first equation by itself. So what I'm going to do, now technically you could do either one, but thanks to the way this is formatted, if I can just get this, get this thing in terms of, I have Q equals something involving P, then I can just kind of feed it directly in and, work out what happens with the FOIL algorithm that we saw in section 2.1. Now, as it turns out, you maneuver the algebra around, you're going to get the following. So Q is going to equal P minus 10. So now I can take that guy, shove it in right there, and I'll have P minus 10 times 2P minus 10 equals 2100. Now, when you've been at this as long as I have, you might just leap immediately to what the quadratic looks like. I'm going to go ahead and FOIL this thing out and then move over the 2100 separately because I've got board space and time to work with. So the first terms, P times 2P, 2P squared, P times negative 10 is negative 10P. So I'll write that out. Negative 20P comes from my inner terms. And then I'm going to have a plus 100 in the back. Okay. So now, like we saw in section 2.1, I can subtract over the 2100. I can combine the terms that both just have a P and not a P squared. So I have 2P squared minus 30P minus 2000 equals 0. Now, this is something we could use the quadratic formula on this. It turns out, sort of like that last example we saw, this actually factors relatively cleanly. Like I said, if you want to use the quadratic formula, have at it. Again, you will end up at the same place. But if I divide by 2, that gives me P squared minus 15P, not 30P. I was about to forget to divide all my terms. Then I get minus 1000 equals 0. Now, as it turns out, again, if you wanted to use the quadratic formula here, I totally get it. But the factorization is actually not terribly painful in this instance because, 1000 you can break down as 40 times 25. And conveniently enough, if you arrange the sign so the 40 has a minus on it, it's going to look like P minus 40, P plus 25 equals 0. Again, you get to the same place if you use the quadratic formula. Have at it. Don't feel obligated to use, the approach I'm using right here. Anyway, so now setting this guy equal to 0, I get a p-value of 40. Setting this guy equal to 0, I get p equals negative 25. Now, a negative price point doesn't really make sense, right? So if you look back at the directions for this particular problem, it specifically points out that, focus only on positive values. It says non-negative, I think. Yeah, it allows them to be 0. Again, not terribly likely in an actual market situation, but we don't want a negative price or a negative quantity. So that guy's goofy pants. We throw him out. So our equilibrium price is 40. And since we already have a handy formula that tells us what Q is in terms of P, our equilibrium price is 30. So the equilibrium point Again, remember, WebAssign usually likes these as a Q comma P coordinate pair. So we list the quantity first, so 30 comma 40. Okay, so we've taken a look at the supply and demand thing, and we ended up with a quadratic function even when it wasn't apparent that we had a quadratic in the first place. So I didn't want you to get ambushed by those come homework time in WebAssign. So now let's wrap things up by revisiting sort of this cost profit, cost revenue profit stuff. All right. So anyway, because it's actually kind of easy, there's a similar problem that comes up in the homework exercises, and it's easy kind of to get crossed up on what's going on here. So you're given that your company has fixed costs of $28,000 and a variable cost per unit of 2/5 X plus $222. What will often end up happening is students will kind of forget what they need to put into that cost function. So remember, C of X looks like that. Fixed cost plus variable cost times X. Even though that variable cost has an X in it, we still need to multiply by X. So in this case, that ends up giving us 28,000 plus, then we take that 2/5 X plus 22, or plus 222, and we multiply that thing by X. So when we work this out, like I said, I like rearranging it so the X squared term is in the front. If you wanted to leave it in the back, you could, but so there's my cost function this time around. 2/5 X squared plus 222X plus 28,000. So the revenue, our sale price is, as you said, we're given the selling price is $12.50 minus 3/5 X. So remember, that looks like a linear revenue function, but remember, we need to take the price and then multiply by X here. So we get 1250 minus 3/5 X times X. Don't forget that times X. It's really easy just to assume, well, oh, that's my revenue. But that's not the entire revenue. That's just the price per unit. We like to assume we're going to sell more than one thing, yes? So, all right. So a revenue function, once we distribute the X, will be 1250X minus 3/5 X squared. All right. Now this guy needs to leave so we can work out the profit function, because we need the profit function to determine break even. So the profit function, like we've said, and in the interest of time and board space, I'm not going to write out this thing minus this thing in parentheses. I'm just going to give you sort of the finished product here. So when you combine these two guys appropriately, I got negative X squared, you have negative 3/5 X squared minus and a 2/5 X squared. So you end up getting a negative 1 up front. Then we have plus 1028X minus 28,000. And like we've seen before, if we want break even, we're going to set this bad boy equal to 0. Now, as it turns out, in this instance, once again, the quadratic formula works just fine. Feel free to go that route. But the factorization, again, kind of ends up jumping out at me because I can technically divide by -1. I'm actually just going to write a negative out front, like I factored it off. So this is now positive, negative, positive. And as it turns out, 28,000 is 28 times 1,000, right? And oddly enough, if you add 28 and 1,000 together, you get 1,028. So technically we need minus signs because that would be negative without the minus there. Again, if you just wanted to multiply the whole thing by -1, that works just as readily. So we'd get X minus 1,000 and X minus 28. So we break even at those two guys. All right, so we've got our break even points. All right, so we got that guy. Now, The next couple of problems ask about the maximum revenue and then the maximum profit. So if we want to maximize our revenue, and for some reason we don't care about overall profit, we just want as much money coming in as possible. Here's our revenue function. It's written backwards, but the coefficient of x squared is my a, so a is -3/5. My b would be the coefficient of x, the 1250. So if I work that out, I get negative b, so we have negative 1250 over 2 times -3/5. Don't forget the 2. I nearly forgot to write it down, so that would have messed things up quite heartily if I had. So when you work this out, it's not a clean decimal, or it's not a clean integer rather. You end up with a decimal part, but I rounded it to 1042. And then we get, when you plug 1042 back into our r of x function, you get the rather robust sounding $651,042. That sounds really nice. The problem is, you might have already thought about this, again, it's just revenue, it's not profit. We're not taking cost into account. And for what it's worth, we already know that we were breaking even at 1,000, so trying to make more than 1,000 might feel a little weird. So anyway, let's take a look at this. So we're asked to maximize profit. I just erased the function that I was wanting to keep up here, so let's see. Let me reproduce that guy real fast. My profit function looked like that. Negative x squared plus 1028x minus 28,000. Max profit is going to occur at the vertex of our profit function. So negative coefficient of x is 1028 divided by 2 times my a, which in this instance is -1. And that gives me 514 for the production level that maximizes profit, and P of 514, when I worked that out, shouldn't be approximately, because, so when I worked that out, I got $236,196. So again, just taking the 514 and plugging it back into this guy right here. Now, the discrepancy is, well, how is my revenue so massive? Well, the catch is, to make that many units, your costs are also massive. And thanks to the fact that this is where our max profit occurs, it's downhill after this point. So we're actually losing money if we make and sell this many things. We basically outstretched our, I guess our manufacturing pipeline or something like that. I'm dangerously close to talking outside my depth, so I'm going to stop there. But all right. So the last thing we're asked for is, what is the price point that actually produces that max profit? So we can basically take this 514 and plug it back into the price function that we were given in the first place. So 1250 minus 3/5 times 514. And when I work out the arithmetic there, that gives me a price point of $941.60. I'm not quite sure, maybe this is an appliance of some sort. I'm kind of at a loss as to what most, high grade, like a high grade television maybe? Well, high grade televisions would be in the thousands, but you get the idea. All right, so we've wrapped up our applications on how to use quadratic functions to do some more cost revenue, market, supply demand type stuff. So we're going to change gears again moving into the next chapter. It's not just going to be now we have a third degree, thing. We have x cubed instead of x squared. So we're going to change gears rather heavily moving into the next chapter. So that's a thing.